We're now going to do a few examples to actually
So
show
I'm
you
going to
why
do
the
a
trig functions
DVD
are
commentary
actually
style
useful. So let's get
critique of
started
this
with the problem.
lesson.
Let's say I have
The lesson
this
is
right
about what's called right triangle trigonometry. This is a topic that's taught nowadays. It's taught as early as 6th grade, but it could come up in almost any grade
the right
between
angle.
6th and 10th
And let's
grade.
say I know that the measure of this angle is pi over 4 radians. And I'll just write rad for short.
Now this is a
If the measure
problem.
of this angle is pi over 4
This is the
radians,
first
and I
example
also
he's
know
doing
that
of this
triangle
topic, and he's using what's called radian measure. Radian measure is something that's taught in 10th grade, and even when it's taught in 10th grade, it doesn't have to be taught in the very beginning of the course. Sometimes it is. So using radians instead of degrees here is very unusual. I've rarely seen one of these so-called SOHCAHTOA questions where the angle's been given in radians.
So let's figure out what we know and what we need to figure out.
Notice that he's also made the hypotenuse 10 root 2, which, for a very first example, these are pretty complicated looking numbers for a fairly easy concept.
Right? And what are we trying to figure out? We're trying to figure out the hypotenuse, the adjacent side to the angle, or the opposite side to the angle. Well, this is the hypotenuse. We already know that. This is the opposite side. Excuse me. This is this is the opposite side.
That might have been a first one.
The yellow side is the adjacent side, right? It's just adjacent to this angle.
Take back my bless you if it was a cough.
We know the angle, we know the hypotenuse, and we
you could
want
have
to
the
figure
bless
out
you
the
either way.
adjacent side. So let me ask you a question. What trig function deals with the adjacent side and the hypotenuse, right? Because we have the adjacent side is what we want to figure out, and we know the hypotenuse. Well, let's write down our mnemonic just in case you forgot it. So, toa. So which one uses adjacent and hypotenuse? Right, it's ka. And ka, the C is for what? The C is for cosine. Cosine of a angle, let's just call it any angle, is equal to the adjacent over the hypotenuse. So let's use this information to try to solve for this orange side or this yellow side. So we know that cosine of pi over 4 radians, so let's say cosine of pi over 4, must equal this adjacent side right here. Let's just call that A for adjacent. The adjacent side divided by the hypotenuse. The hypotenuse is this side, and in the problem we were given that it's 10 square roots of 2. 10 square roots of 2. So we can solve for A by multiplying both sides of this equation by 10 square roots of 2, and we will get, because right, if we just multiply times 10 square root of 2, these cancel out, and then you get a 10 square root of 2 here. So you get A is equal to 10 square roots of 2 times the cosine of pi over 4.
This looks very complicated.
Now you're probably saying, Sal, this does not look too simple, and I don't know how big the cosine of pi over 4 is. What do I do? Well, no one has the trig functions or the values of the trig functions memorized. There's a couple of ways to do it. Either I could give you what the cosine of pi over 4 is, and that's sometimes given in a problem, or you can make sure that your calculator is set to radians, and you could just type in pi divided by 4, which is roughly 0.79, and then press the cosine button. You finally know what it's good for, and you'll get a value.
Most calculators nowadays you type
cosine
and then the pi over 4.
Where you could look up what cosine of pi over 4 is in a table.
Trig
Since I don't have any of
degrees.
that at my disposal right now, I'll just tell you what the cosine of pi over 4 is. The cosine of pi over 4 is square root of 2 over 2. So area, so A, not area, A, which is the adjacent side, A for adjacent, is equal to 10 square roots of 2 times square root of 2 over 2. Remember, to get the square root of 2 over 2, you might be a little confused. You're like, how did Sal get that? All I said is the cosine of pi over 4 is square root of 2 over 2. And that's not something that, well, actually, this one you might know offhand because it's a 45-degree angle. But This isn't something that people memorize. This is something you would look up, or it's given in the problem, or you'd use a calculator for.
Yeah, but if you look it up,
and in a
or
calculator,
if
of course,
it's a
wouldn't give you
calculator,
square root of 2 over 2. It would give you a decimal number.
you get the decimal. So why not write the decimal here?
But anyway, I told you
because a student who's following along at home is not going to be seeing square root of 2 over 2.
What's the square root of 2 times the square root of 2? It's 2. So that's 2, and then that cancels with that 2, and so everything cancels except for the 10. So the adjacent side is equal to 10.
Okay, this is not a great first
example
for students, particularly if they might be in 6th grade trying to learn this SOHCAHTOA concept.
Let me delete this. Give me 1 second. This is one of the few modules that I'm not generating the problems on the fly, because I need to make sure that I actually have the trig function values before I do the problem.
Whoa!
So let's
he
say
just
I
admitted
have
that all the others he's done
right
on the fly
triangle.
with no preparation.
Another right. I probably should have deleted that last one. So let's say this is my right triangle. How much time do I have? I have 4 minutes left. So this is my right triangle, and I know the angle. Let's call this. Well, I know this angle right here
degrees
is 0.54 radians.
No.
And I also know.
Again, just to remind everybody,
this side right here.
In all my maybe 20 years of teaching,
and I want to figure out.
Very unusual. I don't think I've ever really seen in a book an example of this SOHCAHTOA concept where the angle's given in radians. It's
the opposite.
It's just
side,
given
right?
in degrees. It's just the way these problems are. Not that it's not possible to do in radians.
The adjacent
but
side,
what's going to happen now? What if you have a student who gets all their questions and the questions are all in degrees? Are they going to convert to radians because they see it this way? I don't know. You definitely want to have at least one example that uses degrees.
Right. TOA uses opposite and adjacent. OA. It reminds me of the. Well, anyway. So T for tangent, right? TOA. So tangent is equal to opposite over adjacent. So let's use that. So let's take the tangent of 0.54 radians. So the tangent of 0.54 will equal the side opposite to it. So that's 3, right? The opposite side is 3 over the adjacent side. Well, once again, the adjacent side is what we don't know, so we have to solve for A. So if we multiplied both sides by A, we get A tan of 0.54. And we could do that because we know it's not 0 equals 3. Or A is equal to 3 divided by the tangent of 0.54. So once again, I don't have memorized what the tangent of 0.54 is, but I will tell you what it is because you also don't have it memorized, or you could use a calculator to figure out if you had a radian function. The tangent of 0.54 is equal to, let me make sure I have this right. Oh, right. The tangent of 0.54 is 3/5. So then A is equal to 3.
So if a student has a calculator, they're not going to get a fractional. Exactly. They're going to get some kind of decimal.
And once again, how did I get this 3/5?
Instead.
Well, I just told you, or you could use a calculator to know that the tangent of 0.54 is 3/5.
Okay.
And of course, I'm using numbers that work out well just so that the fractions all cancel. But so we know the adjacent side is equal to, when you divide by a fraction, it's like multiplying by the numerator, multiplying by the inverse. So times 5 over 3. So the adjacent side is equal to 5.
Okay.
There you go. So let's just think
those
about
are
what
examples.
I always do.
He's going to summarize,
but what sides
the big
I
issue
have,
here,
what side I want to solve
as I've said a few times,
but
it's really significant, is the
and I said, what
the
trig
idea of these
function
radians,
involves
because
those two
it's just not how
sides,
these
the
questions are
opposite
done.
and the
It's
adjacent.
just
I wrote down SOHCAHTOA.
grab any book,
TOA,
and these
opposite and
questions
adjacent,
are done with degrees.
Tan of the angle,
Makes it easy to
I said
understand.
tan of the angle
0.54
is equal to the opposite
radians,
side divided by the
something
adjacent
like
side. That's right here.
29 degrees or
solve for the
something.
adjacent
It's
side,
just
and
not
of course I used a
intuitive concepts
calculator, or
anymore
I told you what the tangent
when he's
was,
doing it
0.54.
in this way with radians.
I think I'll do a couple more of these problems in the next
That's what I
module,
have to
but
say
I'm out of
about
time for now.
this lesson.
Have fun.